It is now day 23 of the eruption of the Mayon Volcano in the Philippines, which is considered to be one of the planet's most perfectly symmetrical volcanoes. The last several days have seen not only an increase in pyroclastic flows from the volcano, but also a dramatic spike in earthquakes. During the first 17 days of Mayon's eruption, only 47 earthquakes occurred, largely due to the movement of magma occurring at an average rate of a little less than 3 a day. Then, the number of volcano-tectonic earthquakes dramatically increased, jumping from 2 on June 24th to 24 on June 25th to 102 on June 26th. June 27th had a similarly large number of earthquakes occur, totaling 107, with this representing more than had previously occurred during the entire eruption's first 19 days. At some volcanoes, such an increase in seismic activity while it is erupting often signals the intrusion of a new batch of magma. For example, during the 2021 explosive eruption of the La Soufrière volcano on St. Vincent, a fairly effusive eruption turned into a highly explosive one after dramatically increased seismic activity occurred and the associated batch of magma reached the surface. Since Mayon has also produced highly explosive eruptions where what I just described actually occurred at this volcano, you might wonder if the same thing is about to occur and result in a highly explosive eruption. Luckily, in my opinion, this rapid increase in volcanic earthquakes was not caused by the intrusion of a new batch of magma at Mayon, but rather something else which is fairly harmless and might seem somewhat unexpected: rain. While groundwater exists essentially everywhere on the planet, rainfall can have a particular effect on the hydrothermal systems of some volcanoes. I am specifically referring to water heated at depth by magma or rock heated by this magma, which then heats the water, which eventually travels to the surface as either steam or through fumaroles, hot springs, and sometimes geysers. These hydrothermal systems utilize water and sometimes can be filled to fairly high levels via periods of heavy rainfall or intense snowmelt during periods of unusually warm weather. If sections of ground in these hydrothermal systems become overloaded with groundwater, the pressure the water places on overlying rock, when associated with occasional increases in residual heat from at-depth magma, makes it far more likely to fracture overlying rock and move upwards. While this water is fracturing rock, it occasionally encounters a fault, reducing the friction present on the fault line, allowing for shallow earthquakes to occur. This series of events is why the Lone Valley caldera in California often sees a greatly increased number of earthquakes during high periods of snowmelt on hot days in the spring or early summer, or why Mount Rainier between April 23rd and April 27th of 2023 experienced an earthquake storm when temperatures were 20 degrees above normal. In the case of Mayon, all 5 days so far in the eruption with the highest number of earthquakes occurred when it rained, while all 5 days with the lowest earthquake totals occurred on days when it did not rain, as shown by color-coding days where it did rain blue. So, not only were these earthquakes caused by rainfall, but they were also incredibly low energy, unlike what would be expected if a new batch of magma was intruding underneath Mayon. As a quick correction, 5 stated on June 23rd that the two-pronged lava flow traveling down the Misi and Bonga gullies had reached 2,500 and 1,800 meters from Mayon's summit respectively. It turns out that this figure was an overestimate, as 5 incorrectly interpreted some falling lava blocks from parts of the lava flow which crumbled as part of the actual lava flow length. As a result, 5 came out with a revised figure, meaning that the lava flows by June 26th have only reached 1,300 and 1,200 meters along the two aforementioned drainages. Yet, by the following day, the lava flow along the Misi drainage had increased approximately 300 meters in length. What all of this means in the context of the eruption is that since the lava flow length was overestimated, the revised figure means that lava is now less likely to travel outside of the 6-kilometer exclusion zone, as it would take a longer period of time. While the amount of sulfur dioxide emissions at Mayon has for the most part remained below 1,000 tons a day like would be expected in a VEI0 eruption, over time the local minima figures have seemingly continued to progressively increase as the eruption continues. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank my new Patreon Chief Tom for supporting this channel.